Hi, my name is Vincent, and today I want to take you all through a crash course in high school geometry. So we're looking at the June 2019 New York State Geometry Regents. The PDF to this could be found in the description below. So try it out first and then follow along with me. So for question one, we have these three triangles here, and what we're trying to find is which sequence of rigid motions maps triangle ABC to triangle A prime, B prime, C prime, and then that triangle to A double prime, B double prime, C double prime. So the first thing we need to do here is just look at the transformation that's going on from this triangle ABC to the prime triangle. And as you can see, this triangle is flipping over the x-axis. So the first thing happening here is a reflection in the x-axis, which eliminates choices 1 and 2. Now, just by process of elimination, we could rule out 3 and say it's choice 4, because the reason why there's no translation here is that if there was a translation, this triangle would be facing the same direction in quadrant 4. Like, B double prime would be facing down. So that's why the second transformation going on here is a rotation. And it looks like a rotation of 90 degrees about the origin counterclockwise. So choice 4. Now for this question here, what we need to do is calculate the population density. So we have this table of values, and to find the population density, we're going to be dividing the population by the land area. So for this part, all we're doing is just dividing the first column by the second column. So for the first one, I'll only do the first one, and then I'll let you follow along with the rest. So we're dividing 200,536 by 706.82. And if we look, the population density for the first one to the nearest tenth is 283.7. And the units would be, people per square mile if we had to give it units, but it's multiple choice. So we only care about the numbers. And if you do that for the other sections as well, for Dutchess, Niagara, and Saratoga County, you should have these quantities when you divide these populations by the respective land area. So all we're looking for is which one is the greatest. So that's going to be for Niagara County. So question 2, we're going with choice 3 here. Okay, for this question, there's a lot of visual prompts here. So the question is, if a rectangle is rotated around one of its sides continuously, what 3D figure is formed? The reason why there's this delicious chicken up here is that this is how I see it in my head. We have to be able to see what it means to rotate something. And the shape is actually going to be a cylinder. So if you want to see the geometry behind it, here's a cylinder. And if we were to look at one of the cross sections here, so if we were to look all the way through the cylinder, if I take a cross section this way, we have a rectangle, and as it rotates, it's going to form a cylinder. A good concept of this in real life is the revolving door. You see all these glass pieces here are rectangles, and as it spins, it forms the it forms the cylindrical shape as it spins around. So choice 2 for this one. Okay, for this question here, what we're looking for is which transformation would carry a parallelogram onto itself. And what that means is that when we perform the transformation, we're looking at the same identical figure, and all the points are going to lie in like the same respective places here. So process of elimination here will work. So if we look at the line y equals x, the reason why choice 1 is no good is because let's say I take point A and I reflect it over this line, it would land me at the point 3, 4, and this is clearly not on the original parallelogram, so choice 1 is out. Now for the same reasoning, choice 2 is out, because if I look at the reflection line y equals negative x, if this is point M prime would be over here, and it's clearly not on the original parallelogram, so choice 2 we could cross off here. Now, choice 3 is also no good. To rule this one out, let's say we carry point A through a 90-degree rotation counterclockwise. This would send A to the point -3, 4. And negative 3, 4 is somewhere up here. Because see, the highest y value on this parallelogram is 3. So negative 3, 4 would be above the original parallelogram. So by process of elimination, this is choice 4. But if we wanted to actually be convinced that choice 4 is correct, not just from process of elimination, to rotate something counterclockwise about the origin 180 degrees, all you do is you just take the points and you negate them. So A prime in this case would be negative 4, negative 3, which would map A to point H. The image after following a 180 rotation here would be 2, negative 3, which would map us to point T, and the same technique on H and T would map us to A and M. So it is going to be choice 4 for this question. All right, for question 5, what we're trying to find here is the scale factor of dilation. So we're starting off with a line segment CD, and we know the coordinates of both of them. And then we're finding out the image of this line segment. So we have the coordinates for C prime and D prime. So the way we're going to solve for the scale factor is we could use this formula that any point xy dilated by a scale factor of k centered at the origin is simply like all we need to do is multiply x and y by the same constant k. So what we're doing here essentially is, let's say I take the x value for coordinate c, then the x value for the coordinates for c prime is simply the original x value 6 times k equals 9. So I'm just multiplying by the scale factor to get my image here. So then when I solve for k, we divide by 6 on both sides. K equals 3 over 2. Now, if you're not convinced at this, remember, we could have picked any other points as well. Like, let's say I picked the y value for d and the y value for d prime. Then negative 8 times the scale factor k should equal negative 12. And when we divide by negative 8 here, negative 12 over negative 8 also simplifies to 3 over 2. So no matter which pair we pick, the technique is going to get us the same scale factor no matter which pair we pick. So choice 1. Okay, for this question here, we're dealing with a tent in the shape of a right pyramid, and it has a square floor. So what I would do here is, this is not given to you, but just draw out a pyramid to the best of your ability and label the base. It's a square base, and each side is 8 feet long. The height of the tent is 6 feet. So if we label from the center of the square to the top of the pyramid is 6 feet, then all we need to know to solve this is the equation for the volume of a pyramid, which is 1/3 the area of the base times the height. So then all we have to find here to solve this, the area of the base, since it's a square, is just the side squared. So 8 feet times 8 feet, which would be 64 feet squared, or 64 square feet, we could say. And then times the height. The height is 6 feet. So we're just going to substitute for h. So then from this part of the question here, 1/3 of 6 is equal to 2. And then if we multiply this out, 64 times 2 is 128, and feet squared times feet is cubic feet. But this is multiple choice. We only care about the numbers. So for this one here, we have choice 2. Okay, for question 7, we have more with dilation. So this line is being dilated with the center of dilation at the origin. So the concept that you need for this question is that, if we read this here, dilated lines are parallel, which in other words means that the dilated lines have the same slope. So the strategy here is to take the line that we're given, and when we solve this for y, it's going to tell us the slope of the line. So we're going to add 3x to both sides. And next step, we're just going to divide by 4. So what we have now is y equals 3/4 x plus 2. Now the reason we do this is that in general, y equals mx plus b, the coefficient of x tells us the slope. And since parallel lines have the same slope, all we need to do to answer this is find an equation that has a slope of 3/4. And that would be choice 2. So for question 7, we have y equals 3/4 x plus 8 is parallel to this original line here. So for question 8, we have intersecting lines, and we want to know which information is sufficient to prove the two triangles are congruent. Now, the moment you have intersecting lines, the first thing I like to label is the vertical angles that are formed, because these vertical angles here are always going to be congruent. So once again, we got to go with process of elimination. So why is choice 1 no good? Like, why is it not enough to say AB is parallel to CD? That's not sufficient to prove these two triangles are congruent. The reason being, the only thing that parallel lines establishes is that the alternate interior angles here, like angle A and angle C, are congruent, and then angle B and angle D are congruent. So this would be sufficient to show that they're similar but not congruent. So choice 1 is out for us. So now if we label choice 2, AB is congruent to CD, BE is congruent to DE. All right, this one here is the angle side-side theorem. This is a word you should never say in class, so you should never write it on a test because it will get you the question wrong. So we're going to cross off 2. The angle side-side theorem is not valid for showing two triangles are congruent, so we cannot use that here. So now for choice 3, we have E as the midpoint of AC, which would establish that AE is congruent to CE. This is no good because it only establishes a pair of sides and a pair of angles congruent. So this doesn't match any of our postulates for proving triangles congruent. So this one is out. So choice 4 here, and we'll see why. If BD and AC bisect each other, well, for one, we already have this label that these two would be the same. But if they bisect each other, then BE is also congruent to DE, and this would be a model for the side angle side postulate. So choice 4. Now, the technical way of doing this would be to use the idea that sine and cosine are what we call cofunctions, which means that sine and cosine are equal when they are evaluated at complementary angles. So what we're really looking for is which angle is complementary to 57 degrees. So if we do 90 minus 57, we'll see the missing angle is 33 degrees. However, considering this is a multiple choice test, well, this part of the test is, the other way of doing this would be to type in the question. So we have sine of 57 and we get this decimal. And if we just start writing in answer choices, like tangent of 33, which doesn't match the original, and then finally we get to cosine of 33, we'll see that sine of 57 and cosine of 33 are exactly equal in decimal value. So that's another way of saying choice 2 without actually having to know the cofunction concept. For question 10, the goal is to find the volume of a hemisphere. So what we need to know is the formula 4/3 pi r cubed. This is the volume of a whole sphere, but in this case we want to find the volume of a hemisphere. So we're going to divide this whole thing by 2. So for a question like this, one thing to be on the lookout for, if you rush and you write 4/3 pi and then you plug in 12.6 cubed and divide by 2, you're going to wind up with choice 2, but be careful. This test is loaded with bear traps. If you rush too quick, you are going to step in a bear trap throughout this test, so please take your time. The radius is half of the diameter, so please make sure that you are dividing the diameter by 2. We're going to have 6.3 centimeters. So when we plug into our formula, we have 4/3 pi, and then we have 6.3 to the third power, all divided by 2. So we go to the calculator, alpha y equals enter, helps you write in fractions, especially when you have a fraction in a fraction. So we have 4/3 pi is second, and then this caret up arrow button, and then we have 6.3. So 6.3, we hit the up arrow to the third power, and this is all over 2. So to the nearest tenth, this is going to work out to 523.7. So for question 10, we have 523.7 cubic centimeters, but in the multiple choice, we're not worrying about the units. Okay, for this question here, what I like to do, well, I'll get to that in a moment. What we're trying to find first is the length of BC that would make AC parallel to DE. Now, in order for these lines to be parallel, that would mean that angle A and angle BDE are the same, and then BED, this angle would match angle C. which would make this big triangle similar to this smaller triangle up here. So what I like to do in these types of questions is I like to draw the triangles separate. So if we name them individually, the small triangle would be triangle BDE, and the big triangle would be triangle BAC. So if we start labeling this here, BD is equal to 5, so we can label it here and here. DA is equal to 12, which tells us the entire segment BA is 5 plus 12. So this part here we could just call 17. And then BE is equal to 7, so we could label it here in the small triangle. And we're trying to find the entire length of BC, which we could call X. Now the reason I like to draw them separately is that when you set up the proportion, it's much easier to see it when you have it drawn out this way. So let's say I compare the left side to the right side. I'm comparing 5 over 7. That's going to be equal to the ratio of the left side to the right side in the bigger triangle. So we would set up 17 over x here. So then we just have to do the algebra. So 5 times x is 5x, and 17 times 7 is 119. So then we're just going to divide this by 5, and that's going to be a little less than 24. So I'm guessing 23.8 is going to be x. But obviously if it's a test, use the calculator just in case your mental math is off. So let's see. So 119 divided by 5 is in fact 23.8. So choice 1 for this question. Okay, so for this question here, this was not included in the question, but you're going to see why in a moment, like why it's here. But a quadrilateral must be a parallelogram if. Now, if you just memorize the theorems for what it means to be a parallelogram, or how we could show that a quadrilateral is a parallelogram, then we could just say choice 3. If one pair of sides are both parallel and congruent, that's enough. But the key to doing really well on these types of tests is being able to say why the wrong answers are wrong. So why is 1 no good? If only one pair of sides are parallel and one pair of angles are congruent, so in this case here, we have parallel sides and a pair of congruent angles. But this is an isosceles trapezoid, which is not a parallelogram. So 1 is out. Now if we go forward with the other choices, one pair of sides is congruent, so the slant sides are congruent, and one pair of angles is congruent. So once again, this describes an isosceles trapezoid, which is not a parallelogram. So 2 is not enough to show that a quadrilateral is a parallelogram. And for choice 4, if the diagonals are congruent, this is a property of isosceles trapezoids. So that still is not enough to show something is a parallelogram. So for 12, we got choice 3. Okay, so for this question here, we have intersecting chords, and we're told that EM is 8 units long and RM is 15 units long. And we want to know what are potential values for JM and MT, or TM. So the idea, what we need is that when we have intersecting chords, the product of the segments are equal, which means that 15 times 8 is equal to JM times MT. So if we simplify, 15 times 8 is 120. What we really need to do in this question now, if we understand the concept, is multiply all the numbers and the answer choices together until we wind up with 120. So if we start going through, let's say choice 1, we're doing 12 times 9.5 and not 120. So we try this for choice 2. 14 times 8.5 is 1 shy, so not 120. All right, 16 times 7.5. And this is the 1. So this is 120. You could check choice 4, but it should not multiply to 120. Okay, so for this question here, we have triangles Joe and Sam. And let's go ahead and label these. So J-O-E. And the order that we labeled J-O-E in this, we're going to follow that same sequence in the next triangle. So S-A-M. So the first letters should be in the same location, the middle letters and the last letters. So we're told that angle E is congruent to angle M, and EJ is congruent to MS. And we want to know which mapping would not always lead to these two triangles being congruent. So the same joke that we made before, this is never allowed on a test. You can never use the angle side-side postulate. You can't say that out loud in class, so you should definitely not be writing it on a test. So think about which pair of congruent sides would make angle side side. Well, if this was marked off, if side JO and side SA were marked off as congruent, this would model the angle side side postulate, which is not a postulate. We call that the donkey theorem in some cases, but this would not work. And this corresponds to choice 4. If you look at the other ones, like J and S mapping would establish angle side angle. This one would establish angle angle side, and this would establish side angle side. So 4 is the only one that doesn't work here. Okay, so for question 15, we have a right triangle and a perpendicular line is drawn to the hypotenuse. So what we could do first is just label everything. So AB, the hypotenuse of the big triangle, is 9. BC is equal to 6. DE is equal to 4. And we want to know what is the length of AE. So we're looking for this piece here. So the idea of how we're going to do this question is we need to make use of similar triangles. Now, the two triangles that are similar is the big triangle ABC, and then this little triangle here, triangle ADE. Now, the reason why we could say they are similar is that they share angle A, and they also have a 90-degree angle in both of them. So angle-angle similarity tells us that these triangles are similar. So we need to use concepts of proportions. Now, in simple language, we just have to have a creative way of comparing the sides in both triangles. So let's say we look at the red triangle. We're looking at, in this case, 6 represents one of the legs of the triangle, and it's shorter than side AC. So let's say we're comparing the short leg to the hypotenuse. So the short leg is 6 divided by the hypotenuse is 9. And if we look in the yellow triangle, the short leg is 4 divided by the hypotenuse of the yellow triangle is x, because it's across from this right angle here. So if we just solve this, we'll have 6 times x equals 36, x equals 6. So that's one way of going about this. If this doesn't convince you, you could also use concepts of trigonometry to answer this. This is, if we use the mnemonic SOHCAHTOA, we're going to pay particular attention to sine. And let's say I want to look at sine of A. Sine of A in the yellow triangle would be 4 over x. But since the yellow and red triangle are similar, they're going to have the same trig ratio once they're reduced. So sine of A in the red triangle would be 6 over 9. So if we look here, see how we have 4 over x equals 6 over 9? We get the same thing. So we know for sure that x equals 6 is going to be good here. Okay, for question 16, we want to look for the equation that represents a line parallel to this equation, passing through the point 1, 3. So one of the formulas that we need for this question is y minus y1 equals m times x minus x1. This is the point slope form equation. And the given point represents the x1, y1. So what we need to write the equation of a line is a point and a slope. But the slope that we want to use is going to be the slope from the given line, because in order for our line to be parallel to this one, it has to have the same slope. So we're going to take this equation and solve it for y. This is the same as one of the earlier questions, so this concept showed up twice for this particular test. So we're just solving for y, so we do plus 2x on both sides. And now we're going to divide by 3. Okay, and this tells us, for this question, the slope is 2/3. So we have our x1, y1, and we have our slope of 2/3. So now just plug in. We have y minus 3 equals 2/3 times x minus 1. So in this case, we just match it. It's going to be choice 2. Okay, so for question 17, we have a rhombus. The diagonals are drawn in. We have the perimeter is 68, and the length of one diagonal is 16. We want to know the length of the diagonal IE. So what we want to make use of is that in a rhombus, all 4 sides are the same. So if the perimeter is 68, and let's say each side is x, then 4 times x would equal the perimeter. And to solve for x, all we have to do is divide by 4. And that tells us x equals 17. So the missing sides are all 17 units long. And you could even check if you add them all up, it's going to work out to 68. Now, another concept that we need is that when diagonals intersect in a rhombus, For one, they're perpendicular because it's a rhombus, and in a parallelogram, the diagonals bisect each other. So if TG is 16, that means each part here is 8 each because the diagonals cut each other in half. So what we need to find here is the length of the other diagonal. So then what we can make use of is that for this type of triangle, this is a Pythagorean triple, that this is an 8, 15, 17 right triangle for all 4 of these here. If you're not convinced, you could always check by using Pythagorean theorem. Like that's how you would solve for the missing side if it wasn't a Pythagorean triple. But this will work out to be 15 units for each of these right triangles here and here. So then the total length of the diagonal would just be 15 plus 15. So it's going to be 30 units long. All right, for question 18, we have 2 secants. The secants are lines that intersect, or line segments that intersect the circle at 2 locations. And they're meeting at a common point outside the circle called point P. And the name of the first secant is ABP, and the second one is CDP. Now, this was not given to us for the question, but I recommend drawing as much as you can. The measure of the arcs, we have AC is 72 degrees, and arc BD is 34 degrees. So anytime we want to find an external angle formed by 2 intersecting secants, we're subtracting the larger arc minus the smaller arc, and we're dividing all of that by 2. So if we work this out here, this is going to be 38 degrees divided by 2 when we subtract the numerators. Well, what's in the numerator? So the missing angle P is 19 degrees. Okay, question 19 is a bit of a tricky question. My advice for this is they give you scrap graph paper. Once again, this was not given to us in the question, but this would be a situation where I would use the graph paper to help us. So first thing I would do is plot these. So negative 8, 4 is the coordinates for A. And the coordinates for B are 10, negative 2. And then I'll kind of explain what the question's looking for here, because it could be a little confusing. So we're looking for the coordinates of point C, and the location of C splits this line segment into a ratio of 2 to 1. So what I recommend doing for these kind of questions is that when I look at the ratio, I add those numbers together, and the sum of those numbers represents the number of parts to this line segment. So what I want to do essentially is break the line segment into 3 parts. And the way we're going to do that is we're going to use the concept of slope. So if we look here, the rise over the run, to go from point A to point B, I'm going from 4 to negative 2, so I'm going down 6, and then from negative 8 to 10, I'm going over 18. So once again, I'm going down 6, and I'm going over 18. Let's make that a little neater. Whoops. There goes all of it. So down 6 and over 18. So if I want to break this into 3 parts, I'm going to divide this by 3. And the simplified version of this would be to go down 2 over 6. This is not the completely simplified version, but it's the one that we need for this question. So now I'm just going to follow that. I'm going to go down 2. So we're going down 2 units, and then over 1, 2, 3, 4, 5, 6. And then once again, down 2, over 1, 2, 3, 4, 5, 6. And if I do it again, it's going to bring me to point B. But you see how it broke this line segment into 3 parts. And the one I want to go with, like the question now is C going to be here or here? And C is going to work out at this location because remember, we needed the ratio of AC to CB to be in the ratio of 2 to 1. And if we look, you see how segment AC is twice as long as the other segment CB. So now we just have to know the coordinates here, and the coordinates for C are 4, 0. And just know this technique also works when you're dilating lines, but it's an overlapping concept, but this question could be a bit tricky. Okay, so for question 20, we have the equation of a circle written out, and we want to know what's the coordinates of the center and what's the radius of the circle. So this formula you absolutely need for this question, and the trick to this question is you have to be skilled with completing the square. So what I like to do for these questions is I write out the x terms x squared plus 8x. And then I leave a space, and you'll see why I'm doing that in a moment. And then I write out the y terms, so I have a plus y squared minus 12y, and I leave another space. And then this is all equal to 144. And what we have to put in the space is we have to add a number that makes the x quadratic and the y quadratic a perfect square trinomial. Because if you look, we have x minus h squared. So we need this to factor in such a way that the factors are exactly the same. And the way we come up with the missing number is we look at the b term. The b term is the coefficient of x. We divide it by 2 and square it. So if we take 8 divided by 2, 8 divided by 2 is 4, and 4 squared is 16. So what we just did was 8 over 2 squared, and then that number is going here. So same process over here. Negative 12 divided by 2 is negative 6, and then squared is 36. But remember the golden rule of algebra, whatever I add to the left side of the equation, I have to do the exact same thing to the right side of the equation. So we're going to do plus 16, and we're going to do plus 36, because we can't just introduce numbers to one side and not the other. So then if we simplify this, this is 52 plus 144, which is 196. And now this will factor nice. X squared quadratic is going to factor to x plus 4 times x plus 4. So we have x plus 4 squared. And then the second one is going to factor to y minus 6 times y minus 6, which is y minus 6 squared. So then the center, what you have to do is just switch the sign of the number in front of the x. So the center here is going to be at, instead of positive 4, we're writing negative 4. And instead of negative 6, we're writing positive 6. And then to find the radius, you just take the square root of 196, and it's 14. So since this could be expressed as 14 squared, this tells us the radius for this question is just 14. So that corresponds to choice 4. Okay, for this question here, we have a parallelogram. One side is extended, and we're told for this question that segment ST is congruent to segment SP. Angle R measures 130 degrees, and the goal is to find the measure of angle PST up here. So for this question, you have to know properties of parallelograms, and one of the properties is that opposite angles are congruent. So that means I could label this angle down here 130 degrees. Another concept that we need is that along a straight line, we have 180 degrees of angle measure. So if we subtract, we have 180 minus 130. The missing angle on that line is 50 degrees. Now, it may not seem like we have enough at this stage, but we were told that two sides of this triangle are congruent, which makes this triangle isosceles. And we know in an isosceles triangle, the base angles opposite the congruent sides are also congruent. So angle T, I could say, is 50 degrees. So then to solve for x, I'm just doing 50 plus x, which is x plus 100, equals 180, because the three angles of any triangle in 2 dimensions makes up 180 degrees. So that tells us that the missing value for x, the angle is 80 degrees. So choice 2. Okay, for this question, the diagram is not drawn, but it really helps for these kind of questions. So we have a 12-foot ladder leaning against a building. So you don't have to actually draw a building out, but just know what each part of the triangle represents. So this part here is the ladder, the hypotenuse, because it's leaning. The building is here, and the ground is down here. And what we need to find is the measure of the angle that the ladder forms with the ground. So we want to find the measure of this angle here. Now the side lengths, we have to be careful labeling. The ladder is 12 feet, so that's the length of the hypotenuse. But now the value 10 is going to go with the vertical leg here. The reason being, they're telling us that the top of the ladder reaches a window that is 10 feet above the ground. So the window is here, and it's 10 feet above the ground. So this is the quantity that we're labeling 10 here. So if we want to find this angle, what we need to do is choose one of the 3 trig functions here. And think about what we know. If theta is here, this side of the triangle is the hypotenuse. This side is opposite of theta. So when you have the phrase opposite and hypotenuse bouncing around in your head, you're going to go with the function sine. So we have sine of angle theta equals 10 over 12. But in this case here, we don't want to solve for the ratio. We want to know what is the actual angle. So if sine of the angle equals 10 over 12, then the angle is equal to the sine inverse of the ratio. So just know, students often mix these up. Sine, cosine, and tangent, you give them an angle, they tell you a ratio. Sine inverse, cosine inverse, and tangent inverse, you give them a ratio and they tell you the angle. So now we go to the calculator and we're just going to press secant sine and we're going to write in the fraction 10 over 12. And to the nearest degree, 56.4 rounds to 54 degrees. So theta is 54 degrees, which corresponds, I'm sorry, 56 degrees at a little verbal typo there. This was 56.44, which rounds to 56 degrees. Good thing 54 wasn't an answer choice there, or I would have been in trouble. Okay, for the next question, we have an equilateral triangle, so all sides of ABC are the same. E and F are midpoints. So if E and F are midpoints, that means that AE and EC are the same, and then CF and FB are the same. Now the reason we could use a single tick mark for all of them is that AC and CB are also equal in measure, so we don't have to put a double tick mark here. Now EF is 2x plus 8, and AB is 7x minus 2. Now the concept that we need for this question, and the goal is to find the perimeter of trapezoid ABFE, so we're finding the perimeter of this figure here, is that when we connect two midpoints together, the segment formed is called a midsegment, and it's half the length of the side that it's across from, and it's parallel to it. So if this side is half of this side, that means that 2 times 2x plus 8, if we double this segment, it's going to equal the other segment, 7x minus 2. And this is, once again, just coming from the concept of midsegments. So then if we distribute, we just do the algebra. We're going to have 4x plus 16 equals 7x minus 2. Subtract 4x on both sides, you get 3x on the right. Add 2 to both sides, you get 18 on the left. So then you get x equals 6. So let's say I want to solve for the length of AB. We just plug in 7 times 6 minus 2 is equal to 40. But we're not done here. The goal is to find the perimeter of the trapezoid. So this entire side is also 40. So that means each of these pieces is 20. They're 20 each. And then this is equilateral, so this side is 20 and this would have to be 20. And then the midsegment, like we said before, is parallel to this side, and it's also half the measure. So if this is 40, this is 20. But since this was in terms of x, you could also plug x back in to see that this is 20. Now just be careful, make sure when you find the perimeter that you're adding up only the sides that we need. So we have 40 is the length of AB, and then the other 3 sides of the trapezoid are 20 apiece. So it's plus 23 times. So the perimeter of this trapezoid is 100 units. Okay, so for the last question in the multiple choice, we want to know which information is not sufficient to prove that a parallelogram is a square. Now for this, you kind of have to know what the conditions are to show something is a square. And as it turns out, like 1, the diagonals are congruent and perpendicular is enough to show that a parallelogram is a square. The same for choice 2 and the same for choice 4. The reason why I recommend learning those concepts is because when we get to the proofs later, you do kind of have to know that stuff. But why is 3 not enough information? Well, remember, it's good to be able to come up with counterexamples to these questions, which in this case helps us answer the question. But if we looked at a rhombus, the diagonals are perpendicular and one pair of adjacent sides are congruent. In fact, all the adjacent sides, all the pairs of adjacent sides here are congruent. We see how a rhombus is not a square because the angles at the corners are not 90 degrees. So choice 3 is our solution to question 24. Okay, this is going to conclude this video. If you found it helpful, please click like and subscribe below. Stay tuned for the part 2s, but if you have any other requests, please leave it in the comments section below. Thank you for watching.